So hello everyone, this is our fifth lecture as a part of our revision series for the upcoming prelims 2025, and the theme for today's discussion would be a specific topic from geography. It's going to be a discussion on the different climatic zones on Earth. The reason why we take up this topic for discussion is it has a very high benefit in terms of scoring when it comes to prelims. In the last 4 prelims, we have had 4 different questions asked from this particular theme, right? And out of these 4 questions, 3 of them are actually easy. The only difficult question being the 2024 question asked last year, because unless you know the exact difference between China type of climate and marine west coast climate, right, it's only with exact differentiation you can actually get this answer right. So UPSC has made 2024 question on this topic a little bit difficult, but all other 3 questions in the 3 preceding years are relatively easier. You just need to know the basic characteristic types of all these climatic zones. Just by knowing the basic 3 or 4 important points, you can actually get these answers right. It's as simple as that, easy to score in every year when questions are asked from this particular theme, right? So that's why it makes it really important that we try to know about the characteristics of 11 different climatic zones that exist, right? But before we get any further into the discussion, there are a very few basic concepts which I think I should be clarifying it to you, so that every time when I use those words, you don't have any sort of confusion. You should be precise and you should be clear about what I refer to, right? So one is the concept of different planetary winds, second is the concept of ocean currents, and third is the concept of different types of rainfall. Just with these 3 different ideas, we will be able to make sense of all different climatic zones, right? So first, let me clarify to you the idea of planetary winds. Okay, so consider this as Earth, and we have the equator over which the sun's rays are overhead, right? Since sun's rays are very intense on equator, a lot of heating takes place, as a result of which air becomes lesser and lesser denser, it becomes lighter, so air starts ascending, right? Imagine a 3-dimensional profile, or from the surface of equator, let's assume that air masses are going upwards, they are going towards the space, right? Because air becomes lighter, so it starts rising up because of heating. So when air starts moving upwards, every lower layer of air, as it starts ascending, it keeps pushing the upper layer, right? And beyond a point, when air cannot go any further, because air has become so light that it cannot go any further above. Now what happens is air starts being pushed towards the poles, right? Imagine air rising up, and after a point, the new air mass that's still rising, it starts pushing the air towards the north pole as well as towards the south pole. So air mass starts moving towards the poles on both sides, and as they start moving towards the poles, slowly they become cooler, right? And they become more and more dense, as a result of which they start descending. And this descent is what actually happens in 30-degree latitudes on both the hemispheres, both in 30-degree north and 30-degree south latitudes. As the air mass starts moving towards the poles, they become more and more dense, they start descending towards the ground, and this is what exactly happens in the 30-degree latitudes. So air masses starts pressing against each other, and when they hit near the surface of the ground, what happens is the air masses once again split into 2. One mass moves towards the poles, other mass moves towards the equator, right? This is how the first planetary wind from the 30-degree latitude towards equator and towards the poles start, right? So I'll repeat it again. Basically, the air masses from the equator, because of intense heating, they rise up, they go to the upper atmosphere, from where they move towards the north pole and towards the south pole. And when they move towards the poles, after a certain distance, they become more and more dense, right? As a result of which they start descending. This descent happens in 30-degree north and 30-degree south latitudes, right? So that is when, because of continuous descent of air, those latitudes, they are called as high pressure belts, right? Whereas equator, air starts going up, so there is a vacuum created here, right? So that's why equatorial belt is basically a low pressure belt, whereas 30-degree latitudes are high pressure belts. So we call them as subtropical high pressure belts, right? So when the descending air mass in the subtropical high pressure belt, it starts splitting into 2 branches, one branch moving towards the poles, other branch moving towards the equator, right? So let's mark it. That's the first planetary surface wind that we encounter. So from the subtropical high pressure belt, one branch moves towards equator, other branch move towards the poles, right? And what is the situation in the polar region? Just the opposite of equator. At the poles you have extremely cold temperatures, as a result of which air is very, very dense. Air masses press against each other, as a result of which air masses would want to escape away from the poles. They start moving towards the equator, right? So from the poles we have air masses moving towards equator, right? The same has to be copied for the southern hemisphere as well. In the southern hemisphere, from the subtropical high pressure belt, air masses move towards equator. Similarly, in the opposite direction towards the poles, and from the poles air masses move towards the subpolar 60-degree area, right? So just remember this. Okay, so this is the first concept that you have to remember. We are not going too deep into discussing all the different circulation cells created by this air mass and any of this, right? It's not necessary for general studies aspirants. So we just limit our understanding of just the surface winds and in which direction do they actually blow, right? So I used to remember it by remembering the less than sign. You have greater than and less than sign. So this less than sign is how I used to remember the direction of movement of the winds. You see, on this earth we are actually drawing a less than sign. This is the direction of wind flow, right? So this is equator 0 degree, and then you have a subpolar belt at 30 degree, subtropical high pressure belt, and a subpolar belt at 60 degree, and then you have poles, right? Now mark the movement of air. From subtropical you have air blowing towards equator, from subtropical you have air blowing towards subpolar belt, from poles you have air blowing towards subpolar belt, right? This is what we are going to just copy there, right? So this is the direction of wind flow. Right, so you can see that. So it's basically nothing but a big less than symbol. This less than symbol is what is the shape of this pattern, right? Just that the direction I have already explained it to you. It always air flows from a pressure belt where the pressure is high to a pressure belt where the pressure is low. So that's why we mark with these arrows, right? So you see, from 30 degrees north latitude to 0 degrees, these winds are blowing from the eastern direction. So that is east, this is west, north, south. It is blowing, winds are blowing from the eastern direction. That's why we call them as easterlies. Okay, they are also called as trade winds, because a bulk of the trade in the olden days used to happen in these latitudes, right? So that's why it's called as the trade winds. All right. And as you can see here, from the subtropical high pressure to subpolar low pressure, wind blows from the western direction to the eastern direction. That's why these winds are called as the westerlies, right? This is good enough to make sense of the entire discussion. You only need to know what are trade winds and what are westerlies, and you need to know the direction from which the trade winds blow in the northern hemisphere, the direction in which the trade winds blow in the southern hemisphere. Right? In the southern hemisphere they blow from east to west, or you can say southeast to northwest. In the northern hemisphere they blow from northeast to southwest, right? So just know this direction of trade winds and westerlies. So that's the first idea that you should remember. Moving on, the next idea that you should remember, you should be very clear about, is the idea of ocean currents. Ocean currents are nothing but they are just huge blocks of oceanic water moving across the globe, right? You see, a large part of earth is covered with oceans, water bodies, right? And these water bodies are not going to be static. These water bodies are just going to move between amongst themselves, right? But in what direction, in what way, and what are the factors that's going to influence the movement of these oceanic waters? The factors are basically the planetary winds, the surface winds, which actually drag the oceanic water, as a result of which the oceanic water bodies, it keeps moving around, right? That's just one of the factor. Other factor could be the amount of heat received by different parts of these oceanic water bodies, right? The salinity, the difference in salinity is also another reason why oceanic water bodies move from one area to the other. For example, you consider this Mediterranean region, right? It's a closed water body, right? And during the summer months, this entire Mediterranean Sea becomes extremely hot, as a result of which evaporation takes place, and the salinity of Mediterranean Sea actually increases. And the water that's more saline is more dense. It starts sinking below. So this water that sinks below actually slides into the Atlantic Ocean, and the outgoing water is filled by surface water from Atlantic rushing in and filling in the Mediterranean surface seas, right? So this is just an example of how salinity difference because of temperature difference actually induces the movement of oceanic waters, right? Similarly, wherever there are salinity differences, oceanic waters keep moving. So it's a very complex mechanism which is determined by all these different factors, like the surface wind movement, the differential rate of heating between the different latitudes, right, and salinity differences between different areas. All these factors cumulatively play a role in influencing the movement of oceanic waters in different ways, right? So you should understand the idea of warm currents and cold currents, because that's also necessary for us to understand the discussion on different climatic zones, right? So what is this warm current and cold current? Basically, you see here, let's say the trade winds between the tropics, they blow from east to west. Similarly, in the southern hemisphere, they blow from east to west. So when they blow in this direction, what they do is they drag the oceanic surface water, and the oceanic water goes, it hits the continental profile here, and it splits into two branches, one moving towards the North Pole, the other moving towards the South Pole, right? So this entire water body, when it moves towards the North Pole, it becomes chilled, it becomes cooled, right? It becomes cooled, and by the time it reaches from north, it hits the continental profile and it reaches the western coast of Africa. By the time it reaches the western coast of Africa, the entire oceanic water, the ocean current, is actually cold, because it has absorbed the coldness of the northern oceans, right? Same is the case in the southern hemisphere as well. When the oceanic water hits the profile of South America, when it goes towards the South Pole, it becomes cold, and by the time it comes near the coast of Africa, on the western coast of Africa, it's a cold current, right? So same is the case in every other part of the globe as well. So let's take the case of Pacific Ocean. In Pacific Ocean, let's say the planetary winds, they drag the oceanic water towards the west, right? And they come here, they hit the continental profile of Asia, they split into two branches, one moving towards the north, other branch moving towards the south, and as it goes towards the North Pole, it becomes cold, and by the time the same oceanic current reaches the western coast of North America, it becomes a very cold current, right? Similarly, this branch, as it goes to the Antarctic, South Pole, it becomes cold, and by the time it circulates and reaches the western coast of South America, it becomes a cold current, right? So this is the idea behind oceanic currents and how cold currents are formed. All right. The third idea is with respect to the different types of rainfall, right? So convectional rainfall is when, because of heating, water evaporates, it becomes steam, it becomes water vapor, it goes up. When it goes to a certain height, it condenses, because as the altitude keeps on increasing, temperature keeps dropping, because Earth, as you know, is heated from the below, from the surface, right? So at the surface level, the temperature is higher. When you go higher and higher, the temperature drops. So automatically, water vapor, when it goes to higher level, it condenses, falls down as rain. So this is like the very first basic type of rainfall called as convectional rainfall. Orographic rainfall is when moisture carrying wind, right? When wind blows over oceans and seas, it picks up a lot of moisture, and this moisture carrying wind, when it stumbles, when it encounters a huge mountain or a hill, right, this moisture carrying wind cannot cross beyond the mountain. So the mountain is forcing the wind to go upwards. It goes upwards and upwards. As it goes higher and higher, automatically, once again, the same principle, condensation happens. So all the moisture becomes raindrops, rainfall happens, right? So this side on which rainfall happens is called as the windward side. and once all the moisture has got depleted as rain, the wind, when it blows over the mountain, crosses the mountain and goes to the other side, there is no more moisture to condense as rain. So that's why this part doesn't receive any rainfall, and which is called as the leeward side of the mountain, right? And the third type of rainfall that we will be encountering in our discussion is what is called a cyclonic rainfall. Cyclonic rainfall is because of pressure difference that lies between a oceanic body or a sea and a land mass, right? Because land and ocean water bodies, they get heated in different rates, because specific heat capacity of land is actually lower, specific heat capacity of water is higher. You need to give more heat to raise the temperature of a water body compared to land, right? So basically land gets heated fast, it cools down fast. Water gets heated slowly, cools down slowly. So there is always a differential rate of heating and cooling between land and water body, as a result of which there is a pressure gradient, right? And this pressure gradient leads to movement of air masses from high pressure area to low pressure area, right? And when the air masses move from high pressure area to low pressure area, air masses, they are acted upon by a natural force called as a Coriolis force, right? And as a result of this Coriolis force, these air masses, they start rotating, and this rotating air masses, it deposits rain as the rotating air mass travels from one place to the other place, right? So when rainfall is caused because of pressure differences in a local area, because of rotating air masses, such rainfall is called as cyclonic rainfall. Okay, so there are three types of rainfall: convectional rainfall, orographic rainfall, and cyclonic rainfall. That's all. These are the basic concepts which you need to be clear about. And now that you are clear about, let's get into the discussion, and we'll start discussing about the different climatic types. So the first type of climate that we'll be discussing would be the equatorial type of climate, and as you can see from the map here, the areas where equatorial type of climate is pronounced just lies on the equator itself. And there are certain common characteristics shared by all these places, even though they are located in different continents, even though some of the places may be located at a higher altitude. For example, Bogota, which lies in Colombia, is located 8,000 feet above sea level, whereas Malaysia is located on the sea level itself. Despite being located at different altitudes, all these places, they share certain common characteristics, right? What is that characteristic? All these places you will find the rainfall every year goes beyond 200 centimeters. Of course, not all months receive the same rainfall. There is a tendency to have peak rainfall in the month of April as well as in the month of October, because it is in these 2 months, these are the 2 months when equinox actually happens. Equinox is when equator is at its closest to the sun, right? And the exactly opposite phenomenon would be solstice, summer solstice and winter solstice. These are the months when equator is at the farthest distance from the sun, or you can say equator is not exactly overhead to the sun, right? So these are the months when you find rainfall actually slightly dipping beyond the normal, right? So you should understand that not all months receive the exact equivalent amount of rainfall. In the month of April and October, there is a tendency for peak rainfall to be reached in all these equatorial regions, right? And throughout the day, it's simply the same weather conditions, right? It's actually hot and humid throughout the day. There isn't a great range of temperature on a diurnal basis, unlike the desert ecosystem, or unlike the Sudan type of climate, where in the mornings it reaches 40-45 degrees Celsius, and in the night time it comes down to 5 degrees and 10 degrees. That kind of a huge range on a daily basis when it comes to temperature is not something that you find in equatorial region, right? It's almost the same. And not only diurnal basis, even when it comes to annual basis as well, the annual range of temperature also, it's like a flat curve. From January till December, the temperatures are almost the same. There isn't a great difference, right? So that's why you don't have the concept of a clear winter when it comes to these equatorial regions. A very important aspect of equatorial type of climate is with respect to its vegetation. Because of incessant continuous rainfall, the kind of vegetation is very rich in terms of its species diversity, in terms of its density. Another important aspect of equatorial rainforest is with respect to its vegetation. It's because in a very small area you have enormous varieties and species of fauna and flora, right? And not only that, many of the trees that you find in equatorial rainforests, they simply grow very tall to about 200 feet height, right? So they grow up to 200 feet and with their canopy just expanding wider, as a result of which they block the sunlight from reaching all these places, as a result of which the tree that grows next to this tree also tries to compete and grows as tall as possible. Right, so that's why we find layers of canopy, layers of tall trees in equatorial rainforests. Right, and just because all these trees are of so much variety and diversity, commercial exploitation of these trees for timber purpose is also not feasible. Okay, and not only that, all these trees are hardwood trees. You have trees like mahogany, right, and ebony. As a result of which these trees are hardwood, you cannot simply put it on a river hoping that the tree will float and it will come downstream. No, the tree will sink. Okay, unlike you take the case of Siberian forests in Russia, in Canada, you have certain type of forests. The woods are soft woods, they can actually float on the water, right, and all the wood are of the same variety. So you can have standardization of tools, and it's easy to exploit them commercially. But even though the trees here have excellent timber qualities, commercial exploitation is actually impossible, close to impossible when it comes to the rainforests here. All right. So these are some important aspects to be taken note of. And another important aspect is the soil that you find here in the equatorial rainforests are very, very poor and deficient in terms of its nutrients. The reason is because even though a lot of organic matter is available here, because the species are so dense, right, the vegetation is so dense, as a result of which there's a lot of organic matter, leaves, bark, it just keeps on falling. And the rate of decomposition is also very fast because it's a moist environment with optimum temperature. So microorganisms can really have their work on organic matter. They can start decomposing it fast. Everything works fine, but the presence of heavy rainfall leaches out all the organic matter. The humus that is being formed will simply be washed away by the next rains. That's why the soil is comparatively poor in terms of its nutrition availability. Right, so you should not think that just because there is so much of vegetation, the soil should be very rich in its nutrient. No, it's because of heavy rainfall, constant leaching depletes the soil of its much required organic humus material. Right, so with this, I think equatorial climate is done. So we'll move on to the next climatic type, which is the tropical monsoon type of climate. So we are done discussing about the 0 to 10 degree north and south. Those latitudes we are done discussing. Now is the time we move on to the higher latitudes, starting from 10 degrees onwards. Right. So let's discuss about the tropical climatic variations. There are three variations: tropical monsoon, tropical grasslands, and then tropical desert type. Right. So let's have a look into all three of them. The next important type of climate that we'll be discussing would be the tropical monsoon type of climate. So this is a climatic type which is very, very distinguished by the influence of trade winds. Right. You have trade winds. The southeast and the northeast trade winds, right? During the summer months, in the month of March, April, May, what happens is the Central Asian landmass, being a very expansive territory of land, gets intensively heated, right? Because of continuous heating, there is a low pressure zone which is created in the interiors of the Asian landmass. Whereas when it comes to the seas, when it comes to the oceans do not heat up as easily as that of land because of the difference in specific heat capacity, right? So oceans take a longer period of time to get heated up, right? Whereas landmass gets heated up very quickly, as a result of which low pressure area builds up in the north, right? So this leads to a shifting of this particular zone. This zone is what is called as intertropical convergence zone. This is the zone where both the trade winds from the north as well as from the south, they converge, right? So this entire intertropical convergence zone, it simply shifts northward, as a result of which these southeast trade winds, they start blowing on India, right? And when they start blowing over India, they carry moisture with them as they cross over the oceans and they strike against the Western Ghats. Orographic rainfall takes place. Huge amount of rain is deposited along the margins of Western Ghats, right? And same, these southeast trade winds, they continue on their journey. They go and they strike against the northeastern part of India. So that is why when you have the heaviest amount of rainfall that will be deposited in India in states like Meghalaya, Assam, and also in Burma, in Myanmar. These are the areas where the orographic rainfall, as a result of the moisture rich southeast trade winds going and impacting against the Arakan hills of Myanmar, will all give heavy rainfall to these areas, right? And a very distinguishable aspect of the tropical monsoon type of climate is that entire rainfall is concentrated within a span of 3 months, right? For example, from January till December, the entire almost 90-95% of the rainfall will happen in the month of June, July and August, right? And the remaining months are almost dry months. So the type of vegetation that would have evolved in these monsoon lands are the type of vegetation that can sustain prolonged periods of scarcity of water, right? So basically they are deciduous forests which shed their leaves. The trees like teak, trees like sal, what they do is they just shed their leaves in these dry months, right? It's only by shedding they can prevent water loss, because each tree leaf, it's a broad area, it has a lot of pores, as a result of which water evaporates. By shedding the leaves, the tree can prevent water loss, right? And once again when the rainy season starts, once again the leaves will all develop, right? So the common type of forest that we actually find in India, right, in forests of Orissa, Chhattisgarh, Jharkhand, in all these interior forests, we find the tropical deciduous type of forests. But at the same time in Andaman or in the northeast, we have evergreen forests. Right? So this is with respect to the tropical monsoon type of climate, right? And a variation of that would be tropical marine type of climate, which is actually found in the eastern margins of South America, eastern margins of Africa, Madagascar, as well as eastern margins of Australia, right? These regions receive rainfall throughout the year, right? Yes, during summer months there is a tendency to reach maximum rainfall, but apart from that, throughout the year they continue to receive rainfall because they are always located on the influence of the trade winds. The trade winds carry moisture rich wind and they go, and orographic rainfall results in these eastern margins, right? So throughout the year rainfall with a tendency to reach peaks during the summer months would be the characteristic feature of tropical marine type of climate. All right. So this is the next important climatic zone that we have covered, right? So the most distinguishable aspect of tropical monsoon type of climate is a continuous hot season, okay? And even in tropical monsoon type of climate, we don't really have very discernible winter months as such. Even winter would be hot, just that it wouldn't be scorching hot like the summer months, right? So the annual range of temperature is not really very great. Almost it's the same temperature between the summer months as well as the winter months. The range is between 20 to 30 degrees Celsius. Even the daily range, the diurnal range is also not so pronounced. Whereas the other tropical type of climate, be it the tropical desert type of climate or be the tropical savanna type of climate, you find a very good annual range as well as a diurnal range. But that's not the feature with tropical monsoon type of climate. Alright. So we move on to the next type of climate. The next climatic type that we will be discussing would be the tropical savanna type of climate. So tropical savanna type of climate represents a transition from equatorial climate to desert climate. So this is the desert climate and this is where you have equatorial climate. So in between that is where you have this tropical savanna climate, also called as the Sudan type of climate, right? So what is the essential feature of the Sudan type of climate? Just like tropical monsoon, in the 12 months there is a very limited time. It is only in the month of the summer months, June, July, August, these are the times when rainfall is received, but it's nowhere close to the rainfall that's received in the tropical monsoon type of climate, right? In the tropical monsoon type of climate, around 150 to 200 centimeters rainfall is received, right? But here that is not the case. It's on the lower side, you have rainfall only between 50 to 150 centimeters. So that's the range of rainfall that we receive, which means that the remaining months are all completely dry, right? And the vegetation also reflects this particular weather patterns, climatic patterns, right? So the vegetation of the savanna lands is basically deciduous trees, grasslands, thorny scrubs, right? But where are they located? When it comes to zones near equator, you have more of trees, less of grasslands, and less of thorn scrubs, right? But as you move northward, for example, in these regions, you find trees that are far away from each other. You have more grasslands, right? And as you come closer to the desert fringes, you will find trees disappearing. You only have short grasses, and then you have thorns, shrubs, right, which is characteristic of the desert type of vegetation, right? So savanna vegetation is not uniform. It actually represents a continuum from the equatorial type of vegetation to the desert type of vegetation. So in the entire savanna regions closest to the equator, you find more of trees and very long grasses, okay? And as you move closer to the desert type of vegetation, the number of trees actually becomes lesser and lesser, and the trees are far out, they are spaced out far from each other, right? As you move closest to the deserts, you find trees is disappearing, you have very short grasses, and you have a few amount of thorny scrublands, right? So that's the nature of vegetation that you find. And when it comes to the daily range of temperature, you find a huge variation in the daily diurnal range of temperature. It's because skies are clear, there are no clouds or anything. So in the mornings you have extensive heating of land, and in the night time all the radiation is all just sent back to the space. It's all reflected from the earth, right? There are no clouds to hold the radiation back, as a result of which morning the temperature shoots up to 100 degree Fahrenheit, and in the evenings you will find it falling down to 50 degree Fahrenheit. It's like 50% of the temperature is simply gone in the evening times, right? So this great diurnal range of temperature is a very, very defining feature of the Sudan type of climate, right? So this is a difference in the tropical belt itself. Tropical monsoon, you don't have such a daily diurnal range of temperature. The range is not so great. But when it comes to the Sudan type of climate, the daily diurnal range is very, it's on the higher side, right? So that's a very, very essential, important aspect of the tropical savanna, the Sudan type of climate, right? And the reason why rainfall is deficient is that the trade winds are mostly they are offshore, right? So this is a trade wind belt, you know that 30 degrees, so this would be 30. So this would be 30 degree north, right? And this would be the equator. So these are trade winds, but the trade winds are what are called as offshore. They do not carry any moisture with them, they just simply blow over the land, right? And they are devoid of moisture, as a result of which they are not able to give any kind of orographic rainfall. So that's the reason why rainfall is very, very less in these belt, right? And in Africa, it is these trade winds which, when they blow from the north, right? So they are given a name in the coast of Guinea. They are given a name called as harmattan. Okay, so they are dry winds. When they blow from the north, when they reach the coast of Guinea, right? And since it's a coast, basically the humidity is very, very high. People keep on sweating all the time. And when this wind, which is very dry, when it reaches the coast, it gives some kind of a relief, right? Because it lowers the humidity, because it's a dry wind. It absorbs some humidity, so it gives a cooling effect to the place, right? It gives a certain kind of a relief to the coastal inhabitants of Guinea, right? So what I'm trying to tell you is that the winds that blow are winds which are very, very dry. They have very less humidity, okay, as a result of which the amount of rainfall received also happens to be low, right? And the vegetation that has evolved is also reflective of the low water conditions, right? You see, this is how the grasslands look like. Trees are far away from each other. Why? Because each tree has to spread out its roots far and wide so as to search for groundwater, right? And the trees are deciduous because during the entire dry months, about 9 months in a year, it's dry months. In all the 9 months, the trees should shed their leaves so as to avoid transpiration loss, as a result of which deciduous vegetation has actually emerged in these tropical savanna grasslands, right? And very notable aspect of these tropical savanna is that it is very rich in wildlife. Some of the most important national parks in the world, like for example Masai Mara National Park of Kenya, it's all located in these kind of tropical savanna grasslands. Alright, so this is another important climatic zone in the tropics, which is basically the tropical savanna type of climate, also called as a Sudan type of climate. Alright, so we move on to the next type of climate, which is basically the tropical desert. So you will be surprised to find that these tropical deserts exactly lie on the Tropic of Cancer as well as on the Tropic of Capricorn. Right? There are certain reasons why these deserts were formed in the first place. First, as I already told you, the winds are the trade winds. They blow as offshore winds. They are deprived of any moisture content, as a result of which they don't have any moisture to give to these areas. Number one. Second, a very important aspect is the influence of cold oceanic currents. Right? I told you already what ocean currents are, and I told you how cold currents were formed. Right? So the cold current that flows here on the coast of America, it's called as the Californian current. It's a cold current, as a result of which it cools the air above these areas, and then the humidity actually falls down. And when humidity is less, you don't actually have chances of rainfall in these areas. Same is the case with the Peruvian current, which flows adjacent to the western coast of South America. Right? Same is the case with the Canary cold current, as well as the Benguela cold current, as well as the West Australian cold current. All these are cold currents, as a result of which the air around these places becomes less with humidity, as a result of which the chances of rainfall is reduced. Right? So was formed the Mojave Desert, the Atacama Desert of South America, the entire Sahara Desert. Right? And the reason why Arabian Peninsula is actually a desert area, it's because the trade winds are completely offshore. Okay, and this is the reason why Namib Desert is formed, because of the influence of cold current, and the West Australian cold current is the reason why we have a desert on the western margin of the Australian continent. The daily range of temperature in all these deserts would be on the higher side. Right, in the daytime, in the afternoons, the temperature just shoots up to very, very hot, around 40-45 degrees. Right, and in the night times, because of clear skies, why do we have clear skies? Because there is no water vapor here. As a result of absence of water vapor, clouds are not formed. So all the solar radiation that had come in the daytime, it is all now reflected back to the space. Right, so that's why in the night time you find intense cooling happening in these deserts. Right, so the daily range, the diurnal range of temperature is very high in these deserts. Right, and when it comes to precipitation, the precipitation is very, very low. The amount of rainfall received in most of these deserts is less than 50 centimeters in a year. And there are deserts like the Atacama Desert of South America, which for years together does not have a single day of rainfall at all. Aridity will be very, very high in these regions. Right, but at the same time you have deserts like the Namib Desert here, which is very close to the coast. So this is the photo of Namib Desert. The Namib Desert just merges into the ocean. Right, as a result of which there is a lot of moisture in the wind nearby, and this moisture in the wind actually settles down as fog and mist over the Namib Desert. Okay, and this fog and mist actually leads to precipitation, relieving the aridity of the Namib Desert. Right, so you can say that Namib Desert is not as arid as the interior parts of Sahara or the Atacama Desert or the Thar Desert. Alright, the vegetation of these areas have evolved to suit the climatic conditions of this particular place. The plants have developed very, very deep roots, and the plants are something like cacti, right, thorny, leathery plants. They have very thick leaves, which has very less pores, so as to avoid transpiration losses. The leaves have all transformed themselves into needles and prickly structures. Right, it's all a mechanism so that the vegetation can learn to adapt itself to these zero water conditions. All right. At the same time, these deserts are all significant from an economic perspective. It's because it is in these deserts of Australia you have the gold mines, the Kalgoorlie and Coolgardie mines of Australia. They are very rich sources of gold, right? As well as the Kalahari Desert of Botswana, which is the adjacent country to Namibia. So in Botswana you have the Kalahari Desert where you have diamond mines, and the Atacama Desert region, it's a very rich source of sodium nitrate, which is actually used for fertilizers. And recent years, the Atacama Desert has also become a very important place for lithium salt pans as well, right? And goes without saying that Arabian Desert is where petroleum reserves are found, right? So these deserts, they have become economically significant because of the discovery of so many mineral resources. Right. So we move on to the next climatic zone. So now that we have done with the tropics, let's move beyond the tropics. We'll take up the latitude belt between 30 degree and 45 degree in both northern as well as in southern hemisphere. So in the northern hemisphere we have the Mediterranean region, as well as we have parts of western coast of North America, specifically California. And in the southern hemisphere we have certain western margins of 3 different continents. Right. So what's the type of climate that prevails in these places? So we give it a name, we call it as the western margin Mediterranean type of climate, right? So what is the very distinguishing character of this climate? No rainfall in the summer months and excessively high rainfall in the winter months, right? So in the winters, when it's actually cool and when it's cold, that is the time when the heaviest rainfall accrues to these parts, right? What is the reason for that? It's simply because of the shifting of westerlies, right? So I've already told you it is in the 30 degree belt where you have the subtropical high pressure belt, right? Similarly here in the 30 degree belt you have the subtropical high pressure belt, and it is from subtropical high pressure belt to the poles we have the westerlies, right? Similarly, from subtropical high pressure belt to the poles we have the westerlies, right? During the summer months, let's take the case of northern hemisphere. The summer months are in May, June, during those months, right? During those months what happens is this entire pressure belts, they move slightly to the north, right? They move around 10 degrees to the north, as a result of which these westerlies during summer months they become offshore. They start, instead of being onshore, during summer months the entire subtropical high pressure belt shifts slightly to the north, as a result of which these westerlies, they don't blow over ocean and then they reach land. Instead they simply start blowing over land itself, so they become offshore, as a result of which they don't carry any moisture. But at the same time, during winter, around the month of December, what happens is this entire pressure belt, it actually shifts to the south, and when it shifts to the south, now the westerlies, it becomes onshore. It brings moisture and it gives rainfall to this entire belt, right? So it's basically the shifting of westerlies in the winter months southward, as a result of which the westerlies become onshore, thus giving rainfall to the northern part of Africa as well as to the Mediterranean rim of Europe, right? So you can see this pictorial representation. This is the extreme heat conditions which are prevalent during the time of summer in Italy, right? You see people actually taking water from the public fountains and washing their faces. It's because of complete dryness during this period, absence of any rainfall, right? But this is a photo of Libya. Libya is actually in the northern part of Africa. The northern part of Libya actually has a Mediterranean type of climate. So it is during the winter months where you have heavy rainfall as a result of westerlies, right? This is the case with the northern hemisphere, whereas in the southern hemisphere the summer and winter is completely reversed. For the southern hemisphere, the summer months are December and January, whereas winter months would be June, May, July. Those would be the winter months, right? So let's take the example of central Chile. It's a country in South America, So what happens is during the summer months, in the month of December, January, during those months, the westerlies, normally this is their position, but during the summer months the westerlies shift by 10 degrees. So basically the westerlies, this is the new position of westerlies. So there is no action of westerlies in giving any rainfall to Chile, right? But during the summer months, it is these southeast trade winds which actually blow over central Chile, and these southeast trade winds are offshore, they are not onshore, right? They are simply just blowing over the continent, so there is no chance of them giving any rainfall, right? But as the pressure belt shifts northward, that is during the winter month for the southern hemisphere, which is in the month of May and June, what happens is this entire pressure belt shifts to the north. That is the summer of the northern hemisphere. At that time, when the pressure belt shifts to the north, during this time the westerlies now come to their original position, as a result of which now they become onshore. The westerlies are now able to create rainfall to the coast of Chile, as well as to the coast of southeast Australia, as well as to the Cape part of Africa, right? It's basically, the logic is very simple. It's because of shifting of the pressure belts during the summer months in both northern and southern hemisphere, the westerlies have no action to play, right? But during the winter months, because once again due to the shifting of the pressure belts, now the westerlies become onshore, as a result of which they are able to carry moisture laden winds, they are able to provide rainfall to all these places. Alright, so the vegetation also evolves in such a way so as to withstand the prolonged heat periods, right? And the vegetation that you find are citrus fruits type of vegetation, pears, figs, apples, right? So it's those type of plants which have evolved so as to adapt to this particular type of climate, right? So you have the vegetation here. So basically the Mediterranean lands, these are called as the orchards of the world, right? Or you have grapes, oranges, figs and citrus fruits, all of them grown in the different places of Mediterranean, all right? And many of these citrus plants, if you can see the bark has become very thickened, right? So as to withstand the period of extreme heat, the barks have all become thick, and it's from these barks basically the corks for sealing the wine bottles, right? You have corks, so all those corks are made of the barks of many of these trees, right? So it is viticulture and winemaking which forms an important occupation of the people in the Mediterranean region. So some of the best quality wines in this world actually comes from these Mediterranean regions, right? The impact of this Mediterranean type of climate can be felt interiors up to Turkey as well. So that's why Turkey, because of cultivating good quality grapes, is capable of producing some of the finest raisins in this world, right? So this sums up the entire discussion of our Mediterranean type of climate. So we move on to the next climatic type, which is basically the temperate grassland type of climate, which is also called as the steppe type of climate, right? So the areas where this particular type of climate is found can be located within the 30 and the 45 degree latitudes, both in the northern as well as in the southern hemisphere, right? A very distinguishing aspect of these places is that they are located in the interiors. They are not located on the margins of the continent, they are located in the interiors, right? Of course in the southern hemisphere it's slightly different. Southern hemisphere, since the land, the continental size itself is lesser, that's why you have a closer proximity to the coast, right? But taking the case of northern hemisphere, the regions where this particular climatic type is experienced is located in the continental interiors, as a result of which the moderating influence of the ocean is actually absent, and because of that extremes of temperatures are reached, both in terms of annual range of temperature, right? There are days when the temperature goes up to 30 degrees in the summer season, and then there are days where the temperature falls less than 0 in the winters, right? So the climate is extremely harsh in these temperate grasslands, and rainfall that's received is also received only during the summer months, right? So in the case of northern hemisphere, rainfall is received in the month of June, July, those months. When it comes to these temperate grasslands of southern hemisphere, rainfall is received in the months of December, January, right? It's just reversed. So there are definitely in both the hemispheres, at least for 3 to 4 months minimum, there are no rains, And even in the other months, whenever it rains, the rains are just convectional in nature, because the location is so interior. That's why cyclones cannot reach these areas. So orographic rainfall is ruled out. So the major predominant type of rainfall that you find in these areas are, that is convectional rainfall alone, and the rainfall is just better than desert conditions. In deserts, rainfall is less than 50 centimeters, right? But in these temperate grasslands, you find the rain somewhere between 50 to 100 centimeters, slightly better. Okay, but look at the harshness of the climatic conditions, right? Snow covered, very less amount of rain, and that is the reason why you do not have tropical rainforests or deciduous forests in these areas. Okay, so that is why grass grows in these temperate lands. That's why the name temperate grasslands. Okay, and a very advantageous aspect of these grasslands is that they just run for thousands of kilometers long. For example, these steppes, which is there in the southern part of Russia, it's around 2000 miles long and 1000 miles wide, right? Just plain lands. There are no disturbances. The terrain is also not very different, as a result of which huge parcels of these lands can be brought under intensive farming. It can be brought under mechanized agriculture, and that is exactly what has happened to southern parts of Russia as well as to parts of Canada, USA, right? So these areas have become the bread baskets of the world. These have become the granaries of the world, right? Because when you involve mechanization, you achieve better output. The productivity per hectare actually increases, right? So large scale farms are possible in these areas, right? So that is how the agrarian output of all these places have actually gone up, correct? And when it comes to the southern hemisphere, a very notable aspect here is that this annual huge range of temperature that you find in the northern temperate grasslands, that you won't find in the south. It's because of the influence of these warm currents. So we have already discussed what are ocean currents. So these ocean currents, when they start from equator and when they move poleward, as of now they are warm currents. It's only when they go and hit the southern parts and now they come back to the western part of African continent, then they become cold currents, right? So when these warm waters, when they come to the coast of South America or when they come to the coast of Africa, they are warm, right? As a result of which they exercise a moderating influence. So that is why you will not find sub-zero temperatures happening in these grasslands. Okay, and this is why sheep and cattle, since sub-zero temperatures are not reached, sheep and cattle can be reared very easily. They don't have to be kept confined in closed quarters. They can be allowed to just rear in open grounds all through the year, and that's why some of the best sheep rearing areas you find in these grasslands, right? So the pampas grasslands of Argentina, the felled part of South Africa, as well as the downs in Australia, these are areas where there are grasslands, where commercial mechanized agriculture has been made possible, and as a result of improved agriculture and farming, they have also become hotspots of dairy farming as well, right? If Argentina has become a leading supplier of beef in this world, it's just because of the possibility of farming that can be carried out in these areas, right? And the Australian success in dairy farming actually owes its credit to the presence of such huge grasslands which can be brought under cultivation, right? So this is all about the steppe type of climate. A very distinguishing character of steppe type of climate is its extremities of temperature, and in addition to the extremities of temperature you also have rainfall which is only concentrated in the summer months, and that too the rainfall is not as high as the monsoonal type of places. The rainfall varies between 50 to 100 centimeters, right? As a result of which the deciduous or the evergreen type of forests cannot grow and proliferate in these regions, as a result of which grasses take over all these lands. All right. So we move on to the next type of climatic condition, which is basically the China type of climate, right? So the China type of climate is also called as the eastern temperate margin climate, because this particular climatic type is located on the eastern margins of the different continents, right? This is a type of climate in China where the influence of monsoonal factors, influence of convectional factors, as well as cyclonic factors can be seen. It's very, very similar to that of the Indian monsoonal behavior, right? Indian monsoon happens as a result of intense heating of the Asian landmass, as a result of which the southeast trade winds are pulled in a particular direction, right? Same is the case with the China type as well. It's because of intensive heating of the Asian landmass, the southeast trade winds, they start blowing towards the eastern coast of China, and while they carry moisture, they go and give rainfall to these parts of China, right? And also because of local heating, evaporation happens, and convectional rainfall also is also another reason why rains happen to China, okay, these parts of eastern part of China. And in addition to that, we also have cyclonic disturbances which are set up in the Pacific region, and these cyclonic disturbances, as they travel towards the coast of China, they give very copious amount of rainfall, and many a times these cyclonic disturbances are very devastating. They cause huge destruction, as you can see in the image here, right? So this is another important characteristic of the China type of climate, where almost in all these places which experiences this type of climate, you have the influence of windy disturbances. Let it be the tornadoes that you find in Gulf of Mexico, or it could be the bursters that you find in the coast of Australia, right? In all these places with China type of climate, we have windy disturbances which take a make a heavy devastation on life and property, right? So what is the temperature like in parts of China which experiences this type of climate? The temperature is on the extremes, right? Because during the time of summer months, extreme heating of the land masses takes place, so the temperature shoots. And during the time of winters, a reverse phenomenon happens where the land becomes cold very easily, right? And because of land becoming cold, air becomes dense, okay? So it becomes an area of high pressure, and so winds start blowing from north into China, into these places, as a result of which even snow formation takes place, because the polar cold winds are brought from the north to parts of China, right? So the temperature drops down to very, very low levels. So that is why you find this annual range of temperature to be very extreme, right? During the summer months, land gets heated fast, so you get high temperature, and in the winter months, because of the influence of polar cold winds from the north, snow formation leads to very low temperatures, correct? So this extremity in temperature is another important feature of the China type of climate, right? And rainfalls happen throughout the year, but it's more pronounced during the summer months, right? So this is what we find here in China. Now looking at the Gulf of Mexico. In the Gulf of Mexico, the monsoonal characteristics are not very prominent. It's because unlike the Asian landmass, which is very, very big, the American landmass is small, so you do not have that differential heating impact of land very pronounced in North America. So as a result of which, monsoonal reasons are not the main reason why rains fall in these regions, but instead it is due to the influence of warm current. The Gulf Stream, which is a warm current, actually creates more humidity in and around the Gulf of Mexico, as a result of which rains fall, right? And the moderating influence of this Gulf Stream is also found in the weather conditions of this place, right? It's because of the moderating influence of the Gulf Stream, there are no frost formation in these regions, making it very, very suitable for cotton cultivation, right? So certain states of USA, so the states of North Carolina, South Carolina, Virginia, these are all the states where cotton cultivation is carried out. It's because these regions being coastal, they are not covered with frost, and cotton needs at least 200 days of frost-free days, right? Making it very, very suitable for cotton cultivation. Not only cotton, this also becomes an important area for tobacco cultivation as well, right? So the precipitation of this area, it happens as a result of the cyclonic disturbances which happen, and not only that, it's also as a result of the warm Gulf Stream, the Gulf Stream warm current, which actually touches the coast of America, as a result of which the humidity increases and rainfall happens, right? And even in America also, you have devastating windy disturbances like tornadoes, which are basically twisting masses of wind, which leaves a huge trail of destruction wherever it passes, right? So the coastal towns of Miami, these are all areas where tornadoes tend to happen on a frequent basis, right? When it comes to the southern hemisphere, those eastern margins which experiences China type of climate, you will find that throughout the year there is rainfall, because these areas come under the influence of the southeast trade winds. So there is a continuous presence of rainfall, right? And this huge range of temperature that you find in the northern hemisphere, that's not what you find in all these places. The annual range of temperature is also lesser, right? And never does sub-zero temperatures happen in these regions. Okay, so range is small, sub-zero temperatures do not happen in these regions. It's because of the moderating influence of warm oceanic currents, and rainfall is also very continuous, right? Throughout the year you have even distribution of rainfall, right? So you find very good agriculture being carried out in all these places in southern hemisphere which experiences China type of climate. For example, sugarcane cultivation that is grown in the Natal province of South Africa, right, as well as the maize cultivation that's happening in eastern coast of Australia, right. All these are as a result of the very fine suitable nature of climate that you find in southern hemisphere. All right, so we now move on to the next climatic type. So we move on to higher latitudes from here. We move on to the latitudes of 45 degree north to 60 degree north latitude, and similarly we also consider the 45 to 60 degree south latitude as well, right. So the climatic type of this region is called as the cool temperate western margin type of climate, because this particular climatic type is located on the western margins of these continents, right. And this climatic type is also called as the marine type of climate. The reason is because the effect of the oceans is very, very high in moderating the climate of these regions, right. You consider the same latitude, take the case of Siberia. Siberia is located in the interiors, it's continental, so the moderating effect of the oceans is very, very negligible there. It's absent, as a result of which extremes in heat, extremes in cold is reached there. But you take the case of London, this is the graph that shows the annual range of temperatures. You find a very small range. It's because of the moderating effect of the oceans. No wonder this climatic condition itself is called as the marine type of climate. And when you see the precipitation curve, you can see that there is year-round precipitation, but the quantum of precipitation of course varies. For example, in plains of London, precipitation is very low, only around 50 to 60 centimeters in a year. But you take the case of Christchurch in New Zealand, the precipitation is around 200 to 250 centimeters. So it's a wide range of precipitation we encounter in different regions with the same climatic type. There are regions in the same climatic type with just 50 centimeters of annual rainfall, and then there are regions with around 200 to 250 centimeters of annual rainfall. A very big reason why such amounts of rainfall happens is because of the effect of westerlies. Westerlies are constantly onshore on these paths, as a result of which moisture laden winds reach these paths, and orographic rainfall gives way for heavy downpouring happening in these areas. And not only that, London also receives rainfall also from temperate cyclones that form in and around these areas, right. So we can say that onshore westerlies and temperate cyclones are the major reasons for bringing rainfall to all these areas, okay. And just because there is sufficient amount of moisture remaining throughout the year, it allows deciduous trees to evolve in these regions. So we have excellent hardwood varieties of deciduous trees in growing in all these areas. We have trees like chestnut tree, we have trees like willow wood, right. So these are excellent hardwood and used for various timbering purposes. Such kind of trees we find them growing in all these regions, okay. So this is all about the British type of climate, and these deciduous trees, as you can see in the images, they proof themselves from extreme winters by shedding their leaves, right. During winter times, when the amount of sunlight received is low, right, the chlorophyll pigment in the leaves actually becomes lower and lower. So that's why the leaves turn golden in color, orangish in color, right. And when winter happens, when snowfall starts, the leaves are just shed down completely, right. So that's the way how the trees can adopt itself to these seasons. And once again, with the arrival of spring, green leaves are seen once again, right. So this periodic shedding of leaves is again a feature of the deciduous trees that are grown in these marine type of climatic conditions. All right. So it's from here we move on to the interior regions of Asia as well as North America. So these are the areas where you have extremely low amount of temperature, right. The temperature is often sub-zero for most months of the year, and precipitation constantly happens throughout the year. It happens either as rainfall or as snowfall, right? And rainfall happens as a result of convectional factors. Because of excess heating of land, water vapor goes up, brings rainfall. And the other reason why rainfall would happen is because of temperate cyclones, right? So orographic reasons are not going to work out here. It's because these are deep into interiors of the continents, so moisture laden winds cannot reach to the interiors. So that's why rainfall only happens as a result of convectional and because of temperate cyclones. All right. Now coming to the vegetation of these areas, the vegetation of these areas are predominantly coniferous forests, right? So when we say coniferous forests, it refers to softwood variety of trees, and these coniferous forests are also evergreen in nature in these belt. So what could be the reason for that? How can evergreen forests exist here? It's because these are close towards the poles. The amount of heat received by these areas is very less, as a result of which the evaporation, the transpiration from the plants is also lower, right? So which means that the leaves can be evergreen throughout the year, and these leaves have adapted themselves for survival in these harsh environment. How? If only there was a broad leaf, if snow was to fall on the broad leaf, the leaf would just break, right? So that's why the leaves of these Siberian areas, of these cold climatic zones, they have become needle-like structures. They have become pointed, thin needle-like structures, as a result of which they are able to withstand severe snow conditions here, right? And these coniferous trees are excellent softwood, which has a very great utility in timber, in paper industries, in match industries, in building and construction industries where softwood is required, right? And moreover, the possibility, the feasibility of commercial exploitation of these forests is also very high. The reason is, you take the case of equatorial forest, you have so many varieties, species of plants growing in a very small area, right? So cutting a large tree and breaking it into small timber and taking it out of the forest is very, very difficult in equatorial type of forests. But when it comes to these Siberian type of forests, you have a single species of coniferous tree just dominating over hundreds of kilometers, right? There is no other species, and there is no undergrowth below these coniferous trees. If there are so many other small trees, small shrubs, it's very difficult to cut these large trees and take them out. But here you don't see any undergrowth, just these trees. So that's why it becomes very easy. You just have to cut all the trees. All the trees are of the same size, correct? So once they're all cut, they're all dropped onto the frozen river streams. Rivers are all frozen during this period of time in the winters, and once the river thaws in the summer, automatically these logs that are cut, they're all transported downstream, and they'll all be collected downstream, and it will be used for further processing and for other industries, right? So this is all about the Siberian type of climate, also called as the cool temperate type. All right. So from here we move on to the next type of climatic zone, which is the Laurentian type of climate. So let's have a look at the Laurentian type of climate. The Laurentian type of climate is considered to be a mix of both Siberian and the British type, which we have just seen, right? And I'll tell you why it's the case. The Laurentian type of climate is actually found in two distinct regions, one in the northeastern part of North America, and then you have in the northeastern part of China, also including the Korean peninsula and the islands of Japan. So these are the two different regions where you find Laurentian type of climate, right? Why do we say that it's a mix of British type and the Siberian type? First, in the Siberian type you have extremes of temperature, right? Same is the case with the Laurentian areas. This is the temperature profile for New York, this is the temperature profile for Peking. Okay, New York and Peking are two different cities, right? You can find that the summer temperatures go up to certain extreme, which is very similar to that of the Siberian type. But in the Siberia, even in the winters, temperature goes to extreme sub-zero levels. But that's not the case with these two areas. The reason being that it is moderated by the North Atlantic drift, which is actually a warm current. The warm current does not allow the temperature of this coast to fall down to such drastic levels. So this moderating influence of this warm current resembles very closely to that of the British type of climate, because we have already seen that British type is also called as marine type. Why? Because the influence of oceanic currents is very, very high. So that's why the winters in Britain are not so harsh. Same is the case with the northeastern part of North America as well, right? So that's why we say that when it comes to the annual temperature, it resembles a mix of both British type as well as the Siberian type. Not only that, even when it comes to vegetation as well. When it comes to vegetation, we know that in British type of climate you have the deciduous trees, and in the Siberian type of forest you have the coniferous trees, right? So similarly, in both these areas you find a mixed forest comprising of both deciduous as well as coniferous trees. So let's say the latitude of this region starts from 45 degree, goes up to 60 degree. So 45 up to 50 degrees you will find that you have deciduous trees, and it's only above 50 degree you have coniferous trees predominating, right? So even when it comes to the character of vegetation, you find the traits of both Siberian as well as that of the British type mixed and found here, right? And how do these regions receive their rainfall? Basically, this part receives rainfall because of this warm ocean current. Because of the warm ocean current, the humidity of this area actually goes up. When the humidity goes up, it again falls down as rain, right? So that is one of the reasons. The other reason is because you have great lakes, Lake Ontario, Lake Superior, you have all those great lakes here, as a result of which evaporation takes place and rainfall happens. But this is not the phenomenon when it comes to China, right? And moreover, you see the rainfall profile of New York. The rainfall profile is uniform throughout the year, right? This is not the case with China. This is where the difference between these two regions lie. Even though they both have similar climatic conditions and all of that, they both lie in the same latitudes. When it comes to the rainfall profile, the amount of rainfall received in a year and the distribution of rainfall, there is a clear difference between the two. When it comes to this portion, rainfall is uniformly distributed throughout the year. But when it comes to China, you will see that portion, you will see that rainfall resembles that of a monsoon pattern. It's only in the 3 months where majority of the rainfall takes place, and in the remaining 6 months you find only 10% of the annual rainfall deposited, which is very, very close to monsoon type, right? And actually speaking, the type of Laurentian climate that you find here in China, it's also called as the cool temperate monsoon type, because it has a lot of monsoonal characteristic. I'll explain to you what it is. Basically, during summers, the interior part of Asian landmass gets heated, as a result of which the southeast trade winds are deflected towards the interior of Asia, and these southeast trade winds, as they come and hit the coast of China, it is from these southeast trade winds rainfall happens, right? And this happens at the peak of the summer season. So that's why it is in the month of June, July, August, when the heating has all happened, that is when the bulk of the rainfall happens, because of the incoming southeast trade winds carrying moisture, right? So this is very similar to our southwest monsoon that we have in India, right? And in the winter months, what happens is a reversal takes place. In winter months, the landmass here gets cooled very fast, right? As soon as it gets cooled very fast, there is a high pressure belt which sets here, as a result of which air starts flowing from here towards the coast, and this air brings the polar cold winds towards the coast, as a result of which snow formation happens in all these areas. So if you go to Japan or South Korea, you will find that in the winter months it's heavily snowing, and there are areas in South Korea as well as Japan where snow deposition can even be up to 5 feet, 10 feet high, right? So the severe snowing phenomenon is because of the reversal of winds, where wind starts blowing from the interior continent towards the coast, as a result of which the cold winds enter into this region. Okay, so that is why with respect to the way precipitation happens, there is a difference between these two regions. So here the precipitation happens because of the influence of North Atlantic drift, which is a warm ocean current, as well as precipitation happens because of convectional reasons, right? But when it comes to this point, this belt, it's actually because of the influence of southeast trade winds, as a result of which precipitation happens. And in the winter months, because of the reversal seen in the flow of winds, you find the snow phenomenon happening in these areas. All right, so this is all about the Laurentian type of climate. Okay, you should just remember this alternative name for Laurentian type of climate in this zone, which is called as the cool temperate monsoon type of climate. Okay, all right, so we move on to the last climatic zone, which is basically the tundra type of climate. So tundra type of climate is found only in the northern poles, in the northern hemisphere, not in the south, right? Because in the south we only have Antarctica, which is throughout the year covered with ice cap, so there is no vegetation, there is no climatic change or anything. But whereas in the northern hemisphere we find ice melting for the 6 months when the sun is directly overhead of the North Pole, right? You know that in both the poles the sun is only overhead in 6 months. So for 6 months sunlight is received by the Arctic, whereas 6 months sunlight is received by the Antarctic, right? So during the time when Arctic receives sunlight, all the heat from the sun is simply used for melting of the snow, right? And while the snow melts, when there was a snow cover, all the radiation that was received was simply reflected back to the space, and the skies, as you can see, are very, very clear skies. There is very less water vapor in these areas, right? As a result of which skies are clear, so all sunlight that's received, and snow being a very good reflector, it just reflects back everything to the space, and whatever is absorbed by the snow is only used for simply melting of the snow. As a result of which for 6 months the snow keeps melting, and finally this is the surface profile that we arrive at in all these coastal areas, right? So the temperature profile of this entire tundra belt will not be the same. For example, in the interiors of Greenland there is always ice caps, there is no ground visible for any part of the year. But as you come closer to the coastlines, right, you can find that ice melts during the time of summers, and when ice melts, that is when very, very primitive forms of vegetation like mosses, lichens, they start emerging, right? And it's these kind of mosses which becomes the food for reindeers which actually inhabit these tundra region. All right, so these are the very, very primitive forms of life which you vegetation and fauna and flora that you actually find in the tundra region, right? And when it comes to precipitation, convection is virtually absent. There is no heating and evaporation and rainfall that is actually absent in the tundra region. The only way tundra receives any form of precipitation is through cyclonic activity, and that too it is limited to these coastlines, not to the interiors. All right, so the very, very minimal amount of precipitation in the form of rainfall that these areas receive, it's limited to the coastline as a result of cyclonic activity, and that too during the winter months alone. All right, so with this we cover all the different climatic zones. I hope it was very useful for you in terms of learning all the different climatic zones across the world. If it was useful, do share it with your friends, and we'll meet in the next video. Thank you.